This is SpaceTime Series 21, Episode 60, coming up on SpaceTime. Liquid water discovered under the Martian South Pole. The Mars Opportunity Rover could be in real trouble because of the global dust storm enshrouding the red planet. And finding the foundations for massive stars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
What appears to be a huge subsurface liquid water lake has been detected near the Martian South Pole. The 20-kilometre wide lake was discovered buried under 1.5 kilometres of ice and dust by ground-penetrating radar measurements taken by the European Space Agency's Mars Express orbiter. The discovery is reported in the journal Science. On Earth, wherever liquid water exists, scientists find life. And so the search for liquid water is important in the hunt for life beyond Earth. Evidence for the red planet's watery past is prevalent across its now freeze-dried surface in the form of vast dried-out river valleys, gigantic outflow channels, deltas and seashores, all clearly imaged by orbiting spacecraft. Orbiters, together with landers and rovers exploring the Martian surface, have also discovered minerals which can only form in the presence of liquid water. But the climate and environment of Mars has changed significantly over the course of the planet's 4.6 billion year history. And on the red planet today, liquid water simply cannot exist on the surface for any significant period of time. Water does exist as icy permafrost below the surface, and as ice caps at both the Martian North and South Poles. During the warmer seasons on Mars, there have been tantalizing hints of what looks like water seeping out from the sides of cliffs. These features, known as recurring slope lineae, are thought to be meltwater brine. The low Martian atmospheric pressure, which is just 1/99th that of Earth at sea level, means water melting from ice usually sublimates directly into a vapour once exposed to the atmosphere. So, instead of looking for liquid water on the surface, scientists are looking for it underground. The presence of liquid water at the base of the polar ice caps has long been suspected. Studies on Earth have shown that the melting point of water decreases under pressure from an overlying glacier. Moreover, the presence of salts on Mars could further reduce the melting point of water, keeping the water liquid at temperatures well below freezing. But until now, evidence from the Mars Advanced Radar for Subsurface Ionosphere Sounding Instrument, or MARSIS, the first radar sounder ever to orbit another planet, has remained inconclusive. It's taken the persistence of scientists working with this subsurface probing instrument to develop new techniques in order to collect as much high-resolution data as possible to confirm their conclusions. Ground-penetrating radar works by sending radar pulses towards the surface and then timing how long it takes them to be reflected back to the spacecraft and with what strength. The properties of the material that lies between influences the return signal, which can then be used to map the subsurface topography. The radar investigation shows that the south polar region of Mars is made up of many layers of ice and dust down to a depth of about 1.5 kilometres in the 200-kilometre wide area analysed in the study. An especially bright radar reflection underneath the layered deposits of ice and dust was identified within a 20-kilometre wide zone. Analysing the property of the reflected radar signals and considering the composition of the layered deposits and expected temperature profile below the surface, the authors are interpreting the bright feature as an interface between the ice and a stable body of liquid water which could be laden with salty saturated sediments. For MARSIS to be able to detect such a patch of water, the water would need to be at least several tens of centimetres thick. The study's lead author, Roberto Orossi, from the National Institute of Astrophysics in Bologna, Italy, says the subsurface anomaly on Mars has radar properties matching water or water-rich sediments. Orossi says that while this is just one small study area, it's still an exciting prospect to think there could be more of these underground pockets of water elsewhere, yet to be discovered. Scientists have seen hints of interesting subsurface features like this for years, but they couldn't reproduce the results from orbit to orbit because the sampling rates and resolution of the data were previously too low. To resolve the issue, Orossi and colleagues came up with a new operating mode to bypass some onboard processing and trigger a higher sampling rate to improve the resolution of the footprint of the dataset, therefore allowing them to see things that simply weren't possible before. The authors suggest the findings are somewhat reminiscent of similar radar readings of Lake Vostok, discovered some 4 kilometres below the ice in Antarctica. More intriguing, some forms of microbial life are known to thrive in Earth's subglacial environments. But questions remain as to whether underground pockets of salty sediment-rich liquid water on Mars would also provide a suitable habitat, either now or in the past. Basically, what it means is that whether life has ever existed on Mars remains an open question. At least sites like this provide somewhere to look. Mars Express was launched back in June 2003 and will celebrate 15 years of orbiting the red planet on December the 25th this year. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson, an astronomer with the Department of Science.
This news of Mars has just got the whole world, the astronomical world, chattering, and even mainstream media has sort of gone, oh, hello, there must be life.
Yes, that's right.
What's happened here? What have they found?
So this is work that has been published by Italian scientists, in fact, who've used an instrument called MARSIS, or MARSIS, depending on how you pronounce it, which is an acronym, of course, for the Mars Advanced Radar for Subsurface and Ionosphere Sounding.
Good.
MARSIS sounds a lot better. And it's on the Mars Express spacecraft, which is a European spacecraft. So basically, it's a radar instrument that looks down at the planet's surface. It has provided the most detailed maps of Mars's surface because it gives very accurate measurements of the height of the landscape that it flies over. But what has been done now is that the particular scientists who've done this work have looked very closely at the southern polar ice cap of Mars. Mars is like the Earth. It's got polar ice caps. They're a mixture of carbon dioxide ice and water ice. Ours are purely water ice, of course. We're too warm for carbon dioxide ice to form. But those ice caps are of great interest. So what the scientists have done is looked in great detail at the radar reflections that have come back from this region of Mars over many passes by the satellite, because the satellite, goes over this region periodically and lets you make your measurements. And what they found, and it's taken them a few years to actually analyze these data because the observations were taken between 2012 and 2015. What they found is a really bright radar reflection basically from the bottom of the ice layer. So they get a radar reflection from the ice layer and a radar reflection from the rock at the bottom, which is 1.5 kilometers below the top of the layer of ice. But there's a couple of places where they get this really bright reflection at the base of the ice cap, and it's brighter than the rock reflection. And what that tells them, because there's only one possibility for that, is that there is a water interface there. So there's liquid water at the bottom of the ice. Now, we don't know how thick it is because the radar measurements are not yet sufficiently fine resolution to be able to determine, the difference between the bottom of the water ice and, the bottom of the liquid water and the top. But my guess is it's of the order of 100 meters thick, something like that. But it extends for about 20 kilometers.
It's a big lake.
It's a big, big lake, and it's underneath the ice of Mars. In many ways, it's not a surprise. In fact, it was sort of predicted over 30 years ago that we would find these things. That was long before Mars Express or any similar spacecraft had visited Mars. And of course, there is a precedent here on Earth because Lake Vostok in Antarctica is exactly like this. It's under a rather deeper layer of ice. I think it's about 4.8 kilometers thick, the layer of ice in the Antarctic ice sheet. This is only 1.5 kilometers thick, but the phenomenon is the same. You've got basically a large body of liquid water underneath the ice.
Now, people will be saying, okay, if there's water under the ice, why isn't it frozen? Which is pretty, it's an obvious question, but there's got to be a reason.
There is indeed. Well, there has to be, yeah.
Yeah, well, that's
So, you're quite right. The temperature at the bottom of this ice cap, where the ice sits on the rock, is estimated to be, wait for it, minus 68 degrees Celsius.
Ooh.
Now, you and I know that that's way, way below the freezing point of water.
I've measured my wife's body temperature at that when she's in a really bad mood.
I'm not going to go there, Andrew. In fact, I'll leave that one completely alone.
I thought you would.
So you've got to look at what is actually causing the depressed freezing point. And there are two things. One is the pressure of the ice above it. We know that when a layer of ice above a surface like the bedrock, that actually, the pressure of the ice itself causes a depression or a lowering of the freezing point of water.
You can do that experiment at home with an ice cube, can't you? You can just put an ice cube down, put some pressure on it, and it starts to liquefy.
And it starts melting. Exactly. Yeah. That's for exactly that reason. That's right. It is probably that mechanism that helps to keep the Antarctic, the terrestrial, the things on Earth, the lakes on Earth, liquid, because there's 4.8 kilometers of ice, which weighs a lot. Every cubic meter weighs a ton. So it's, it's pretty hefty pressure that's on top of it. And that is certainly helping to keep that water liquid. However, on Mars, you've only got 1.5 kilometers. You've only got 1/3 of the gravity. So you don't have the same pressure. So there must be something else keeping it liquid. And we believe that is due to the presence of dissolved salts in the water, in particular sodium, magnesium, calcium, all of which have been found on the surface of Mars, and in fact have already been cited as being a kind of natural antifreeze that in some circumstances allows you to see liquid water on the surface of Mars. Only small droplets, but it has been observed there because of this natural antifreeze. They can reduce the melting point of water down to minus 74 Celsius.
Wow.
So if you've got these salts in that water, then the freezing point is lower than the temperature, the ambient temperature being minus 68. So that is a pretty cogent explanation for why this is still liquid.
Could there be life there? Is there a sniffle of a chance?
I think there is a sniffle of a chance, but to be honest, and I don't want to sound like a killjoy here,
no,
miserable Fred Watson, there is there's a factor that might argue against that, and that is exactly what we've just been talking about. This extreme salinity of the water is basically brine. It's really strong brine, and some astrobiologists have speculated that the concentrations of these mineral salts are such that they would not allow any microbial organisms to survive. Now, we simply don't know the answer to that. We know that on Earth, microbes exist in all kinds of different conditions. Some like water above boiling point, some like water below freezing point. Can microbes survive in a really heavily loaded, briny liquid? We don't know the answer, but it does kind of argue to some extent against this being a hotbed of life. On the other hand, of course, there is brine in the oceans of the world, and you and I have both noticed that they're quite full of life, really.
Yes, absolutely true.
Yeah.
And has that taken the attention away from some of the ice moons that are further out in our solar system? Because they were certainly seen as potential life candidates.
Yeah, that's right. Look, it doesn't take attention away from them. In fact, in many ways, it's a similar situation. On those ice moons, you've got a layer of ice much thicker than this one. You've got liquid water underneath it, but these are global oceans of liquid water. They're not just 20 kilometers of lake water that we're finding here on Mars. But yeah, there are definitely analogues between the two.
When we ultimately send people to Mars, we're going to need to be able to find a way to survive, and water is essential. Is this potentially a water source that they could use?
It is, but there are probably easier ones to find, because we know that certainly in the northern Arctic of Mars, where the Phoenix lander landed in 2008, that lander sampled the subsurface soil, and only a few millimeters below the surface there is frozen water. It's a permafrost of water ice. So that's a lot easier to get than stuff buried deep down underneath an ice cap. The other thing is we might want to send robotic drills down to have a look at what's in there. But then you've got all these ethical questions that you and I have spoken about before. The fact that terrestrial microbes, we know, are pretty hardy things. They take free rides on spacecraft all over the solar system. No matter how well they're sterilized, there are still a few remaining living organisms on them. Do we want to pollute the potentially pristine environment beneath the ice of Mars?
It's a dilemma because we want to learn. But
we do want to learn, that's right.
In doing so, we could expose a risk. We could create a risk.
This is just the start, because what will happen next, I'm sure, is that we'll have a higher resolution radar systems. There are spacecraft which are planned to reach Mars in 2020 with orbiting components to them. Higher resolution might give us an idea how thick this water layer is. And in fact, you might be able to devise experiments that tell you a little bit about the contents of the water, although there's really nothing like going and drilling holes to find out what it's like.
Stick a tap in it and turn it on and see what comes out.
I think just on that subject, though, Andrew, in many ways, the easier job to do to sample water underneath the ice is to go to Enceladus, the moon of Saturn, where you've got free samples being squirted out from the south. And if you can fly a spacecraft with the right equipment on board, which Cassini didn't have, to sample possibilities of lipids and proteins and things of that sort, amino acids in those jets of ice coming from Enceladus' South Pole, that might tell you much more about the ocean underneath that ice without having to start drilling holes and things of that sort.
If by chance they do find life in this brine on Mars, the DNA will be the interesting factor.
Yeah,
if it's
absolutely.
the same as life on Earth, then we know that the planets have been talking to each other and perhaps making love.
The question is there one single origin of life in the solar system, or were there multiple ones? And that's a question we do not have the answer to, and it's a very interesting one.
And if there were multiple, all we have to do is find life somewhere else and test the DNA.
That's right, exactly. That's all we have to do. But the bottom line is, if there are, if you do that and you find that you can put down life on Mars to a completely different origin from life on Earth, then the assumption must be that life is fairly common throughout the universe, because if it can do it twice in the solar system, it will do it elsewhere.
That's Dr. Fred Watson speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. There are growing concerns about the safety of NASA's Mars Opportunity Rover. The golf cart-sized six-wheeled vehicle has failed to contact mission managers since being enveloped in a massive global dust storm, which has enshrouded the red planet for well over a month. Steadily dropping power levels aboard Opportunity forced mission managers to suspend science operations on June 8. And 2 days later, on June the 10th, Opportunity made its last contact with Earth before going silent. The dust storm, known as a planet-encircling dust event, or PEDE NASA speak, has blocked out sunlight, preventing the rover's solar panels from charging its onboard batteries. At the time of its last transmission, the rover's energy level had dropped to just 22 watt-hours, and that would have triggered a low-power default mode, placing itself into hibernation and turning off everything but the mission clock until skies cleared. However, if the atmospheric opacity or the solar array dust factor worsens, the rover could experience a mission clock fault as well. In low-power fault mode, Opportunity's master clock is programmed to autonomously wake the flight computer periodically to check battery charge. If there's not enough charge in the battery, the computer will put itself back into hibernation, and the clock will reset to wake up again for another check later on. A mission clock fault complicates the recovery. If the power levels drop far enough, even the mission clock will stop ticking, leaving the rover asleep until the battery charge increases enough to trigger safety programs to wake up the flight computer. An analysis of the rover's long-term temperature trends, conservatively assuming no solar array input, indicates the rover's electronics and batteries will stay above their flight allowable temperatures. But that doesn't stop there being some concern over the health of the batteries if they discharge completely. The batteries might lose some of their capacity if the cell voltages drop to near zero. Meanwhile, NASA's Deep Space Communications Network is listening out for a signal from the rover, telling them that it's still alive. But mission managers don't expect to hear anything from Opportunity until there's been a significant reduction in the atmospheric opacity at the rover's site. Right now, Opportunity is about halfway down Perseverance Valley on the western rim of Endeavour Crater. Launched from the Cape Canaveral Air Force Station back in July 2003, Opportunity landed near the red planet's equator 5.5 months later in January 2004. That was 3 weeks after its twin rover Spirit touched down on the other side of the planet. Both rovers were initially designed for missions lasting just 90 days on the red planet's surface. Amazingly, both kept going for years. It was some 7 years before Spirit finally went silent. That was in March 2010. At the time, it was bogged in a sand dune, unable to position itself so its solar arrays could face the sun. But Opportunity just kept going, reaching its 5,000th Martian day, or SOL, in February this year, more than 14 years after landing, having clocked up some 45.16 kilometres, more than any other rover on any other terrestrial body in the solar system other than Earth. I'm Stuart Gary. You're listening to Space Time. A new study has found that the collapse of molecular gas and dust clouds to create new stars occurs far more quickly than previously thought. The findings, reported in the Astrophysical Journal, provide a new stepping stone, helping scientists understand how the most massive stars in the universe are formed. The study's lead author, Jenny Callahan from the University of Arizona, says there's still an open question in astronomy when it comes to massive star formation. How do stars weighing more than 8 times the mass of the Sun form out of clouds of gas and dust? Astronomers think they've got a pretty good handle on the process when it comes to stars the size of our Sun. Particles in clouds get attracted to each other and begin to clump together, gravity eventually takes hold, and the gases flow towards the centre of the cloud as it collapses. Over millions of years, the gas is put under so much pressure, temperatures increase, causing it to burn. And the star is finally born when nuclear fusion begins in the core of that compressed gas. Theories about how much gas and time it takes to make a star like our Sun can be proven through observations. That's because each stage of a Sun-like star's life, from the collapse of the gas clouds into a pre-stellar core, through to the star's expansion into a red giant and ultimate collapse and demise as a white dwarf, can be seen in examples throughout the galaxy. But astronomers are yet to understand how really big stars can form, those more than 8 times the mass of our Sun. We know when they end their lives, stars of this size explode as supernovae, leaving behind black holes and neutron stars. There are several hypotheses for massive star formation that work in simulations, but astronomers haven't seen those initial conditions out in the real-life universe. One idea involves the formation of massive cores. The massive cores would be dense collections of gas several times larger than the stars they create. It's estimated that for massive stars, the cores need to be at least 30 times the mass of our Sun. But the thing is, it's difficult to find objects like that. The other idea is that multiple low-mass cores are formed within a single gas clump. The low-mass cores grow as they compete for material in the clump, and eventually one of the cores grows large enough to form a massive star. The question is, which of these two ideas is more correct, or is it some combination of the two? The first step in answering that question is identifying the earliest phase of star formation. So the authors set about finding clumps showing signs of collapsing gas motion, known as inflow. Callahan and colleagues selected 101 subjects from a list of more than 2,000 huge, cold and seemingly starless clouds of gas called starless clump candidates. Though astronomers have studied starless clump candidates in the past, many of them focused on the brightest and most massive objects. Callahan's study was unique in that it was a blind survey. Ranging in size from a few hundred times the mass of the Sun to a few thousand solar masses, the starless clump candidates Callahan selected are a representative sample of all gas clouds that have the potential to form massive stars. Using the Arizona Radio Observatory's 12-metre radio telescope on Kitt Peak, Callahan and colleagues detected and tracked radio waves emitted by the molecular gas oxymethyllium, which emits at a specific radio wavelength. The clumps were then further studied using ALMA, the European Southern Observatory's Atacama Large Millimetre Submillimetre Array Radio Telescope, which can peer deeper into the gas and find stars and other objects that can't be seen with a 12-metre telescope. Oxymethyllium is one of the more abundant ion molecules in space. It's a highly reactive ion that would not survive in Earth's atmosphere. When oxymethyllium moves towards an observer, the wavelengths are compressed. When the gas moves away from the observer, those wavelengths are stretched, and so this provides a Doppler shift signature. By analysing the wavelength, Callahan identified 6 starless clump candidates showing telltale signs of collapse, suggesting that the gas collapse happens quickly, accounting for only 6% of the formation process of massive stars. This is SpaceTime. I'm Stuart Gary. 4 more Galileo satellites have been successfully placed into geostationary orbit following their launch aboard an Ariane 5 rocket. Ariane spaceflight VA244 blasted into blue skies from the European Space Agency's Kourou spaceport in French Guiana, releasing the first pair of 715-kilogram navigation satellites 3 hours and 36 minutes after liftoff, with the second pair deploying 20 minutes later. All 4 satellites were released into their target 22,922-kilometre high orbit. They'll now spend about 6 months undergoing tests to verify their operational readiness so they can join the working Galileo constellation. The new spacecraft bring to 26 the number of Galileo navigation satellites now in the constellation. 24 are needed for day-to-day satellite navigation, with the remaining 2 as in-orbit spares. Galileo is ESA's largest ever satellite constellation, designed to provide Europe with a satellite navigation system independent of the American GPS system. The deployment of these latest 4 satellites ends the current phase of the Galileo project. However, work's already underway for a further 12 satellites, which will act as in-orbit spares and as replacements for the oldest of the Galileo spacecraft, first launched back in 2011. And preliminary work's already underway on a new generation of Galileo satellites, planned for launch in the mid-2020s. I'm Stuart Gary. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that heatwave deaths will rise steadily by 2080 as climate change causes the globe to heat up. The findings, reported in the journal PLOS Medicine, claims that if humans can't adapt to future climate temperatures, deaths caused by severe heat waves will increase dramatically in tropical and subtropical regions, followed closely by Australia, Europe and the United States. Meanwhile, a separate study, reported in the journal Nature Climate Change, has been looking at the effects of both climate change and of climate mitigation efforts on the price of agricultural commodities. It's found that stringent climate mitigation policies will have a greater negative impact on global hunger and food consumption than the direct impacts of climate change itself. The most vulnerable areas in the world will be sub-Saharan Africa and Southern Asia, where food security is already a problem. A new study claims kids of lesbian and gay parents experience the same psychological adjustment as kids of straight parents. The findings, reported in the Journal of Developmental and Behavioural Pediatrics, suggest that children with same-sex parents fare well in terms of psychological adjustment and pro-social behaviour. The study adds to preponderance of evidence showing no increase in problems for kids of gay or lesbian parents compared to children of heterosexual couples. The study included 3 groups of Italian parents. 70 were gay fathers who had children through surrogacy, 125 were lesbian mothers who had kids through donor insemination, and 195 were heterosexual couples who had their kids the old-fashioned way. The children were between 3 and 11 years of age. The results showed no major differences in the children's psychological adjustment among the 3 groups of families. In fact, overall, kids with same-sex parents had fewer reported difficulties than children of different-sex parents. In line with previous studies, for all 3 types of families, girls were reported to be more pro-social and having fewer externalizing problems such as aggressive behaviour compared to boys. Across all 3 groups, parents who felt less competent as parents, who were less satisfied in their relationships, and had perceived lower levels of family flexibility reported more problems with their kids. And some indicators of family functioning were better among same-sex parents, especially for gay fathers. This might reflect the high level of commitment needed for gay men to become parents through surrogacy. They also note that gay fathers in the study tended to be older, economically better off, better educated, and had more stable relationships than the lesbian mothers and compared to the heterosexual parents. A new study claims cinnamon oil could be key in preventing superbugs. The findings, reported in the journal Microbiology, come as traditional antibiotics become less effective against superbugs because of their overuse. So some researchers have instead been focusing on traditional agents to modify the behaviour of bacteria rather than killing them off. Scientists investigated cinnamaldehyde, a major component of cinnamon essential oil, finding it inhibited the development of biofilm, a sticky film of bacteria, like the plaque that forms on teeth, that can cause persistent infections, and which resist even the most potent antibiotics. A new study suggests Neanderthals may have used tools to start their own fires. While paleontologists have long known that Neanderthals used fire, they now think they've found the first evidence that they started their own fires and didn't simply just obtain fire from natural sources. The authors studied previously discovered flint tools which Neanderthals had used for animal butchery. They identified mineral traces on the tools, which suggested they've been repeatedly struck with a hard mineral which could be used to start fires with iron pyrite. You can read the full story in the journal Scientific Reports. A new study reports that email continues to be one of the biggest areas threatening cybersecurity worldwide. And while the dangers are very real, there are possible solutions, at least to an extent. To find out more, we're joined by Alex Zaharov-Reut from IT Wire.
There was a report by a company called Mimecast. This is one of these email and data security companies. And they're basically saying that email is still the biggest threat vector for Australian businesses, and that would probably extrapolate to businesses around the world. People have to use email at People said that we'd migrate off to social media or Instagram or Twitter, but no, people still email each other. And unfortunately, email is still the vector where you get various threats. So there are people who are trying to do spear phishing. They're trying to impersonate you or impersonate somebody else or try and fool you as an executive of the company to try and say that, hey, it's the CEO that's contacting you and they want to get this information, get you to respond quickly because they're in a panic and they need you to respond. And so they're using any trick in the book to try and get you to be the weakest link. Now, according to Mimecast, they say that 85% of Australian organizations, and again, this would extrapolate, have seen the volume of phishing attacks increase or stay the same over the past 12 months. But what's happening is that people's attitudes towards email security aren't matching up to this rapid evolution of threats. So you've got 42% of people said they've seen a rise of impersonation attacks for confidential data. 58% of Aussie organizations admit their management teams are not knowledgeable enough to identify and stop an impersonation attempt. And 44% of Aussies believe their CEO is a weak link in the cybersecurity operation. So what this means is, and for just everyday individuals, this means that you must be using some sort of not only internet security software. Microsoft wants to tell you that the one they have in Windows 10 is good enough, but I don't really know if it is. You really should be using something like whatever internet security software you want. If it's got some sort of spam filter or email filtering software for Outlook, if that's what you're still using, definitely turn that on. Take the warning seriously if you're using Gmail when it says, hey, we think this is a phishing email or some sort of email. Don't just blindly click through and say, yeah, I'm going to open it up. And you must have software which is something that can detect dodgy sites and dodgy things, dodgy links that are trying to open up on your computer. And if it detects ransomware, or other malware, it can try and proactively stop it.
And that report by Alex Zaharov-Reutt from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.